Welcome to this video on distributions of the sample proportion part 2. Let's begin. By the end of this video, you should be able to determine whether a word problem meets all requirements of the sampling distribution and use the sampling distribution of a sample proportion p hat to find the probability of events. Let's begin with an example. According to Gallup, about 33% of Americans polled said that they frequently experience stress in their daily lives. Suppose you are in a class of 50 students. What is the probability that no more than 26% of the class will say they frequently experience stress in their daily lives? First of all, what kind of data is being addressed in this question? The attribute we are discussing in this problem is people who frequently experience stress. This is a descriptor, so we must have a categorical variable. Now that we know we have categorical data, we might think that the sampling distribution of the sample proportion would be an appropriate technique. But first, we must check all requirements of this distribution. So the first requirement is that there are two possible outcomes, which we define as success and failure. So we can define success as frequently experiencing stress and failure as not frequently experiencing stress. So remember, in everyday life, success is usually something that is desirable or positive, but in statistics, it's just usually the presence of some sort of attribute. So success is the presence of frequent stress, whereas failure is the absence of it. The trials have to be independent, and we achieve this by saying that our sample size is less than or equal to 5% of the population. Note that our sample size is 50 people. That's pretty easy to assume that 50 is less than 5% of all Americans if we say that Americans is the population we mean to study. The probability of success, P, must be constant across all trials. So remember, the population proportion of people who frequently experience stress was 33% or 0.33. There must be a fixed number of trials, N, also called the sample size. So in this case, we are told that there are 50 students, so N is equal to 50. Next, we require that the shape of the sampling distribution can be normal if and only if we have at least 10 successes and 10 failures. So remember, the way we calculate the number of successes is the sample size times the probability of success, and the way we calculate the number of failures is the sample size times the number of failures. So N is 50, right? We have 50 students. The proportion or the probability of success, meaning probability that they experience stress on a regular basis, is 0.33. The probability that they do not is 100% minus 33%, which is about 0.67. So the number of successes we would have in 50 trials is about 16.5, which is greater than 10. So the number of failures is N times Q, or 50 times 0.67, which is 33.5. This is also greater than 10. And so in conclusion, since we have at least 10 successes and 10 failures, we can assume that the sampling distribution of our p hat is normally distributed. So here's a quick pop quiz before we continue. Which of the following symbols below represents the population mean proportion, and which of these symbols represents the sample proportion? So pause this video, jot down your answer, and unpause it to see if you are correct. So remember, the sample proportion is your p hat, and your population proportion is your p. So now we return to our regularly scheduled programming. Let's go back to our example. So here was our example. Right, so we already decided that all of our requirements have been met, so now we can actually start getting into the process of answering this question. So we first have to find the population proportion, P, then we can find the sample proportion, P hat, and then lastly, we are going to use these values to calculate the population standard deviation, which is called sigma sub P hat. Now you might be thinking at this point, well, gee golly, can't I just put all these numbers into a statistical software program and have it spit out the answer? And the crazy thing is, for these sorts of problems, even if you use statistical software, we still have to do some math before we can even get there. So let's begin. First of all, what is the population proportion? Take a minute, pause this video, see if you can guess. We have two proportions here, right? We have our 33% and our 26%. So which one is our population proportion? Well, the population proportion is the 33% of Americans, right? Americans is our population. So we know that that is our population proportion. So the population proportion is 33%, or remember, when we do our calculations, we just change all these percents into decimals. So we don't write 33, we write 0.33. All right, so then our sample proportion by default, right, because it's the only other proportion that's left, must be the 26%. And we know specifically this is our sample proportion because it's just talking about the people in this class of students. It's talking about out of these 50 students, 26% said that they frequently experience stress. Okay, so now we also want to capture the inequality associated with the statement. It says no more than. So no more than, recall, means less than or equal to. And that's very important when we go to use our technology. So last but not least, we have our sample size n, right? And of course, our sample size is 50 students. So recall that the mean of our sampling distribution is our P, our population proportion. So the mean is going to be 0.33. The standard deviation is given by this equation, and again, even if you use technology at the very end, you are still going to have to crunch these numbers, unfortunately. So remember, P is our population proportion, right? It's the proportion of successes, so in this case it would be 0.33. Our Q is 1 minus P, so it would be 1 minus 0.33, or 0.67, and then our N is our sample size. In this case it would be 50. So we're going to use the values that we just identified in the previous slide to calculate our standard deviation. So here we go. So remember we said P is 0.33, Q is 0.67, and then we're dividing everything by 50, our sample size. So when we do this calculation, this is the value we get, and I myself personally am going to round it to 4 decimal places. So before we proceed, let us talk a minute about rounding. So the standard deviation is almost always going to be an irrational number because you're taking the square root of something that is not a perfect square. So you're always going to have this rounding issue. In general, the more digits you supply, whether you're using a manual calculation or whether you're using technology, it doesn't matter. The more decimal places you use, or the more precision you have, the smaller the rounding error that you generate will be. As a general rule for myself, I like to use at least 4 digits after the decimal point. You can use more if you want, but this is the minimum number I would suggest using to prevent rounding error. So again, the question is asking, what is the probability that no more than 26% of the class will say they frequently experience stress in their daily lives? So no more than is the key phrase here. So that is equivalent to less than or equal to. This is equivalent to saying what is the probability that our sample proportion is less than or equal to 26%. In these types of problems, p hat is our continuous random variable and takes the place of x. So that's all fine and good, but now what? Now what do we do? Well, if you are in a course where you're doing manual calculations, you might just proceed to pop in all of your values into this equation right here, right? We know our sample proportion, we know our population proportion, we already calculated our standard deviation, so we could get a z-score here and then use the z-table to find the area under the curve. That's all well and good, but I want you to really, really think about what you're doing. And to me, if I have to think about what I'm doing, I want to visualize what this is, what this looks like. And honestly, in this case, I feel like in this particular example, using technology makes you think a little bit harder than using this formula. So let me show you what I'm saying by just showing you the technology. So if you're in a course that's using RGuru, I want you to think, where would I even start? What am I trying to do? Well, remember, we're doing a sampling distribution. So what we're doing, we're actually using, believe it or not, we're using the normal calculator. So let's look at our normal calculator and see what values it wants. Well, gee golly, it wants a mean and a standard deviation. I'm so confused. How can we have a mean and a standard deviation when we're not working with quantitative data? I don't understand. What on earth can I put in here if I don't have if I don't have quantitative data? All I have is a population proportion. I do have a standard deviation, right? I mean, I can put my standard deviation in here, right? But again, it's very, very confusing. So just, pause and think about that incongruity. Now this is RGuru. I'm going to click over to StatCrunch for a second because I love the StatCrunch normal calculator because right away, bam, it gives you a picture. It gives you a graph just from the get-go, okay? So what we're doing here, right? What is our mean? Well, our mean is actually going to be our population proportion, right? We know, or we believe, that about 33% of all of our population frequently experiences stress, right? So that population proportion, we're treating that as our mean. That is the center of our data. Then we already calculated the standard deviation, right? So now we want our specific value. So remember, we want to know what is the probability that less than 26% of our sample, of those 50 students, frequently experience stress. So the default setting is less than or equal to, which is exactly what we want. So if I hit compute, I can click that. And then the other thing I love about StatCrunch, I think it's superior, is if I click on this one, right, it shows me here's the mean, right? It right in the middle of my data is my population proportion, 0.33. That's the expected value. So the probability that less than 26% of this sample of 50 people frequently experience stress, the probability is around 14.6%. Okay, and I can go back to, where was it? Here's our guru. So we can go back here and I'll just show you. It gives you the exact same value. It just doesn't illustrate it visually as you go along. But we can do the same thing, type in the values here. And if I select graph, if I select this button, it will give me a picture, of visualization. So as you can see, it gives me the exact same probability, and then I just have to zoom out a little bit and scroll down, and I have this picture. And again, it just frustrates me because it gives you more of an algebraic number line down here. It doesn't do a good job of putting the mean in the middle and then making tick marks of the standard deviations. So let's summarize what we just figured out and what we just learned. So we said that we are treating our population proportion as the mean, right? That's going to be the center of our curve. Then we already calculated our standard deviation. This is our population standard deviation. And remember, our random variable is our sample proportion, in this case 0.26. And of course, the last thing we have to do is figure out what inequality sign we want. Because it is a continuous distribution, we really only have two options. We're either shading left or shading right. I guess we could shade in between, but assuming that we're only shading one side or the other, those are our options. So it says no more than, so that's less than or equal to, or in our guru, we would select below. So again, if we're using technology, we're going to have, some sort of form like this. And again, we're going to be asked for a mean, a standard deviation, a specific value, and an inequality. Okay, and so that these four things cover that. And then the other thing is, as I said before, you can do a by hand calculation where you're calculating a z-score and then using a z-table to find the area to, in this case, the left of that z-score. So finally, we can answer the question, what is the probability that no more than 26% of the class will say they frequently experience stress in their daily lives? And as you can see, this is the output right here. And so I just rounded it to the nearest percent, which is 15%. And again, I know if you're using our guru, this is not what your output looks like, but I just think it's more instructive and beneficial when I'm creating these instructional videos because, like I said, this software puts the mean right there, smack dab in the middle, and then each tick mark represents one standard deviation. So it's more helpful and it maps better onto like the empirical rule. So having watched this video, you should be able to determine whether a word problem meets all the requirements of a sampling distribution and also use the sampling distribution of a sample proportion p-hat to find the probability of events.